Hello everybody, I'm Nathaniel Talon and my title of presentation is Transfer Learning and Data Augmentation Based CNN Model for Potato Late Blight Disease Detection. The table of content of this presentation has introduction, statement of the problem, related work is system architecture, methodology, experiments and the results, and followed by conclusion. As we know, potato is the first major crop in the world and the most consumed crop in Ethiopia. Because of the disease, the productivity of the crop is very low compared to its attainable yield. The statement of the problem of the research is mentioned as follows. The disease, which is the late blight, is caused by an organism called Phytophthora infestant, which has the meaning of plant destroyer. In Ethiopia, the disease is very much devastating, and majority of farmers do not know the cause, epidemiology, and the control of the disease. According to statistics, maximum of 46% yield loss caused by this disease. And also major production areas affected by the disease, and also it is a threat for food security program of Ethiopia and also globally. In this section, we present the related works of the research. We mentioned the two papers in this slide. The first slide is written by M. Sardogan et al. The authors used CNN and the learning vector quantization with dataset size of 500 images categorized under 5 classes. The classification accuracy achieved by this paper is 86%. One of the reasons that the classification accuracy dropped is the similarity between images, which affected while training the neural network. The second paper is written by the Oppenheim et al. The authors used deep convolutional neural network to classify the potato tuber disease. The dataset used contained 400 images with 5 categories, and the pre-trained model used in this paper is VGG, and it achieved 95.8% classification accuracy. In this slide, we summarized the related works done by different authors. The parameter we used to compare this work is the first one is the dataset size, which must be greater than or equals to 1000. The second one is data augmentation technique, whether or not the authors applied this technique. Then the third one is whether the data is real, which is captured from the farm, or a synthetic data. The next one is the transfer learning parameter, which include whether the authors used transfer learning mechanism or they built the model from the scratch. And then the next one is whether the author used CNN or not. Finally, our parameter is accuracy. When we come to the system architecture, the system architecture majorly built using 2 phases. The first one is training phase, the second one is testing phase, obviously. And under training and validation image, as you can see in the image, first we collected the leaf image under training and validation image, and then we passed this data into data preparation stage. And then in the data preparation, with the help of 2 plant pathologists, we labeled the data and then applied a data processing like cropping the image, resizing the image, or increasing or decreasing the contrast value of the image. And then after this operation, we applied the data augmentation, which is basically increasing the dataset size artificially using different different parameters of the augmentation. And then after we finish this data preparation, we feed this image data to the CNN algorithm. Basically, the algorithm is partitioned into 2. The first one is we applied using the pre-trained models. We will discuss in the next slide. The second option is building a model from the scratch. This one is not recommended for a small amount of data. Then in the next phase, is testing image. The model built using different experimentation must be evaluated in this stage. After evaluated, we applied in the predictive model while testing the image and finally generated the result of the proposed works. When we come to the methodology, the first one is the data source. As I mentioned earlier, we collected a potato leaf image from Holeta Agricultural Research Center at Holeta Farm, Ethiopia, and total amount of images 1026 potato leaf image. And while collecting the image, two plant pathologists were assisted in categorizing image in the healthy category and late blight infected leaf category. The other is transfer learning with CNN, which is found in the methodology. Basically, it's discussed about the transfer learning. As we know, currently, transfer learning is one of the powerful methods in neural network, and it simply defined as given a task with the data, and the knowledge generated from this can be used for another task. As you can see from this image, there is a data, and this data is applied for a learning task T1. We call this source domain. After applying this data in this task, we generate a knowledge. And whenever we have similar problem, instead of building a model from the scratch or training this, we can use this generated knowledge for this task. So the whole process is called transfer learning, transferring or sharing knowledge in another way. So the pre-trained model via transfer learning used in this work is the first one is BGG60, the second one is BGG90, and the third one is Inception V3. Generally speaking, the proposed work used 4 experimental scenarios. The first 3 is based on the pre-trained models, which I mentioned in the earlier in this one. And then the first scenario is building a model from the scratch. Even though it is not recommended, we build a model from the scratch for the comparison purpose. The other methodology that we used in this work is the data augmentation. Simply speaking, data augmentation is a technique which is used in the deep learning or machine learning to increase the size of data artificially, because the deep convolutional neural network has millions of parameters. To build a robust model, we need massive amount of data. So if we don't have sufficient amount of data, there are a problem like overfitting, which decreases the accuracy of the performance. So in order to resolve this issue, the data augmentation techniques is necessary. As you can see from this image, there is one sample original image. Applying different augmentation parameters, we generated 12 images, which helps the neural network to learn different features of the image or the data. So applying the data augmentation in the training and validation image, which has a total of 656 image, we increased to 5,248 images. These are some of the parameters that we used in the data augmentation process. For example, that we used the rotation range of value, share range, zoom range, horizontal flip mode, and other parameters of data augmentation. The other methodology that we used is hyperparameter tuning. As we know, the deep neural network has different hyperparameters. So before training the model, we need to have to configure the hyperparameter values. This can be done in different ways. So some of the hyperparameter we mentioned in this slide is optimization algorithm, learning rate, division function, and loss function. So the optimization algorithm helps the neural network to learn fast and attain a good performance. When it comes to the learning rate, it is defined as the amount of weight updated through the training. It has the value range of 0 up to 1, and setting up optimal range or optimal value of the learning rate is very much critical while building a deep learning model. The other hyperparameter is activation function. Activation function is a function given an input or inputs, it results the output. So we have basically like two types of activation function, that the linear and non-linear one. And we experimented on different types of activation function. And while building the model, in each convolution layer, we used the nonlinear activation function. It's called ReLU. This was used based on the experimentation. And also the other one is loss function. Since we have two classes, the healthy and Blight infected class, we applied the binary cross entropy, which is recommended for binary classification problem. As you can see from this image, these are the hyperparameters listed and their values applied in the research. When we come to the experiments, the proposed work conducted experimentation using 4 scenarios. The first one is the pre-trained model. VGG60 is applied. The second one is VGG16. The first one is VGG19, the second one is VGG60, and then the third one is Inception V3. The reason behind selecting this pre-trained model is they achieved a good performance in different competitions and in different research papers. And the fourth scenario is building model from the scratch. And also we applied the cross-validation technique. The number of K that we applied under cross-validation is 5. So we call that the 5-fold cross-validation. The total performance of the cross-validation on the 5-fold is calculated as the performance of I, which I starts from 1 up to 5 over the 5. So by using this formula, we can measure the performance of the model. When it comes to the results, the pre-trained model experimented with several different value parameters. Among them, the Inception V3 outperformed with 5-fold cross-validation. So the optimal hyperparameter configuration are used using the hyperparameter selection method, which I mentioned in the above section. This image shows the Inception V3 validation accuracy in each fold. For example, the first fold is depicted in the validation accuracy 1, which is this line, and totally the 5-fold is depicted in this image. This is for the Inception V3. So the overall performance of the models is generalized as this. This image depicts the training, the validation, the testing accuracy of each pre-trained models. As I mentioned earlier, the outperformance the pre-trained model is Inception V3, which achieved 94.9 on the training, and then 94.11 the validation, and on testing 87%, applying the 5-fold cross-validation. When we come to the conclusion, plant disease is one of the major challenges that hinder agriculture sector, and ineffective management of the crop disease would cause total destruction of the farm. Previously, many researchers have used different traditional machine learning algorithms for solving the problem of plant disease. And in this paper, we have proposed a deep learning model which is capable of detecting plant disease effectively. And the experimentation scenario used are 4, and different hyperparameters were experimented. Finally, from VGG60, VGG19 Inception V3 pre-trained model, and the model built from the scratch, the Inception V3 pre-trained model scored 87 points on testing set. Thank you.